Hello everyone, I am Mrs. Kishori Abhishek Kumthekar, working as Assistant Professor in Fulton Education Society's College of Engineering in Electronics and Telecommunication Engineering Department. Today, we are going to see the practical of to analyze series RLC circuit under the course Basic Electrical and Electronics Engineering of first year syllabus of Dibatu University. First, we see what is meant by the series RLC circuit. A series RLC circuit is an electrical circuit in which a resistor, inductor, and capacitor are connected in a series combination and which is powered by the alternating AC source. The function of a resistor which opposes the flow of current, and the function of an inductor which stores energy in a magnetic field and opposes the change in current, and the function of capacitor which stores the energy in electrical field. The basic terms related to series RLC circuit are inductive reactance, capacitive reactance, impedance, and power factor and the power angle. The inductive reactance means opposition offered by the inductor to the AC current, and the capacitive reactance means the opposition offered by the capacitor to the AC current, and the impedance defined as the total opposition to the flow of current combining resistance and reactance. There are three conditions to analyze the series RLC circuit. First, XL, it means inductive reactance is greater than capacitive reactance. Second, capacitive reactance is greater than inductive reactance. And third, which is a resonance condition, that XL is equals to XC, it means inductive reactance equals to capacitive reactance. For a first condition, inductive reactance is greater than capacitive reactance. The circuit behaves like an inductive circuit and the current lags behind the voltage, and the power factor is lagging, it means less than 1. For the second condition, capacitive reactance is greater than inductive reactance. The circuit behaves like a capacitive circuit and the phase angle which is negative, and the current leads voltage, the power factor which is less than 1, and the leading power factor. And third condition, which is resonant condition, that capacitive reactance is equal to the inductive reactance. The phase angle between current and voltage is 0, so current and voltage are in a phase, and the power factor for this condition is a unity condition. Here some formulas for a calculation. Capacitive reactance equals to 1 upon omega c. Inductive reactance equals to omega L. Omega equals to 2 pi f radian per seconds. Impedance equals to in root r square plus net reactance x bracket square. X equals to XL minus XC. Now we will see the practical of analysis of series RLC circuit. For this practical, we require the practical kit, the single phase auto transformer, and the multimeters to record the values of voltage and current. On this kit, we mounted the series RLC circuit in which we connect resistor, inductor, and capacitor in series with each other. Now we connect the circuit. First of all, we connect the single phase auto transformer to the kit for give the supply to the circuit. For this, first the auto transformer's positive, which is connected to the circuit's positive, auto transformer's negative, which is connected to the supply's negative, and again for the measurement of current we short here the two knobs of the current, and for the measurement of voltage across R, L and C we kept open these knobs. This is the circuit diagram and the observation table of the series RLC circuit. In this we have to measure V in, which is the supply voltage, I in, which is the supply current, voltage across resistor, voltage across inductor, and voltage across capacitor. First of all, we measure the V in, which is the supply voltage. Supply voltage we set to the 30 volt, which is to the V in 30 volt, and the current the value of current which is the 0.20 milliampere, the voltage across the resistor for the 30 volt which is 17.5 volt, the voltage across inductor which is 24.5 volt, the voltage across capacitor which is 37.5 volt. Now we take the readings for 40 volt. For this, set the auto transformer at 40 volt. Measure the current which is 0.38 milliampere. Now measure voltage across the resistor which is 22.4 volt. Now measure the voltage across inductor which is 31.1 volt. Now measure the voltage across capacitor which is 48.9 volt. Now set the input voltage to a 50 volt. Now measure the current across the circuit which is 0.41 milliampere. Now measure the voltage across resistor which is 29.3 volt. Now measure the voltage across inductor which is 39.7 volt. Now measure the voltage across capacitor which is 64.5 volt. Now set the input voltage to 60 volt. And measure the current across circuit which is 0.56 milliampere. Now measure the voltage across resistor which is 34.5 volt. Measure the voltage across capacitor which is 76.1 volt. Now we make the calculations for Vz and cos phi. Now we calculate the value of Vz, cos phi and phase angle from this reading. First we calculate the value of XL, inductive reactance, and XC, capacitive reactance. The formula to calculate XL is 2 pi FL. So the value of XL is 2 pi, the frequency F is 50 and L which is 1 Henry. So the value of XL is 314.15 ohm. Now we calculate the value of XC. The formula to calculate XC is 1 upon 2 pi FC. 1 upon 2 pi, F is 50 Hertz and C is 4.4 microfarad, which is converted into farad, which is 4.4 into 10 raised to minus 6 farad. 4.4 into 10 raised to minus 6, 723.43 ohm. Now we have to calculate the value of Vz for each reading. First we calculate for a first reading Vz equal to in root Vr square plus Vl minus Vc bracket square in root VR, which is 17.5 bracket square, plus VL 24.5 minus VC 37.5 bracket square. By calculating, we get the value of VZ, which is 21.80 volt. Similarly, for each reading, we get the value 21.80 volt, 28.61 volt, 38.38 volt and 46.4 volt. To calculate cos phi for each reading, the formula to calculate cos phi, which is VR upon VZ. For first reading, we have to calculate VR 17.5 divided by VZ 21.80. So we get power factor 0.80. So now similarly we have to calculate cos phi for each reading. For first reading, cos phi is 0.80, for second 0.78, third 0.76 and fourth 0.74. Now we have to calculate the power angle for each reading. For power angle, we take cos inverse of this power factor. So first 36.86 degree, second 38.73, third 40.53 and fourth 42.26 degree. Take three conditions for this circuit. Here the calculated value of XL is 314.15 ohm and XC is 723.43 ohm. So the value of XC is greater than XL. Here the second condition is occurred, XC is greater than XL. So the circuit mounted on the kit, which is the inductive circuit, hence we are conclude that the circuit mounted on the circuit mounted on the kit, which is the capacitive circuit. And now we check three conditions for the circuit. First one, XL is greater than XC. Second, XC is greater than XL. And third, XL equals to XC. Here the XC is greater than XL. So the circuit mounted on the kit, which is the capacitive circuit, and the power factor, which is the leading power factor and having the value less than 1. So here we conclude that the circuit mounted on the kit, which is the capacitive circuit, and the power factor is leading power factor. Thank you.